In this video, we're going to begin our introduction talking about trigonometric functions. But before we can really dive into that, we want to make sure we understand that with a lot of the trigonometric functions that we talk about and most of the discussion we have for this class, it relates to right triangles. So if you maybe have forgotten right triangles, so let's look at something like this. I don't like the way that looks. Let's flip that around. There we go. So when you have a right triangle like this, you have, of course, your right angle is over here. And let's label these sides A and B. And we always use C to label the side that is opposite the right angle. And of course, this side is called that fancy word, hypotenuse. And when we have a right triangle, the thing that relates all of the lengths of the sides of the triangle together is the Pythagorean Theorem, which says a squared plus b squared equals c squared. Now, in a lot of the examples that we have, draw the picture. Drawing the picture helps you see how to label everything in the right triangle, helps you identify what the hypotenuse is. And again, remember, I cannot stress this enough. The hypotenuse is the side that's going to be opposite the right angle. And he is always going to be over here by himself when it comes to the Pythagorean Theorem. So, we're going to be using this guy a ton because if we have a right triangle, which for most of the problems that we have this course, they will be right triangles. If you know two lengths, you can find the third one by using the Pythagorean Theorem. Now, to understand that you may end up with answers that are radicals that you need to simplify. So don't just throw it into the calculator and write some kind of crazy decimal. You want to make sure that your answer is exact, unless, of course, something like MyMathHub or your instructor says to round to so many decimal places. Well, with the Pythagorean Theorem, we have nice solutions to this called Pythagorean triples. These are nice integer solutions to the Pythagorean Theorem. The most common one that you're going to see is 3, 4, 5. And these are really just ratios. So that means that if I have a right triangle that has lengths of 3 and 4 for the legs, that means that for the hypotenuse, it's going to be 5. When we write these Pythagorean triples, the largest number that you have must be the hypotenuse. Now, you may remember this from geometry, you may not, but whenever you have a triangle set up, like look at the one that I have here at the top of the screen. This one right here looks to be the smallest angle. This one is the middle, and then, of course, the right triangle is the largest angle. The side that is opposite the smallest angle is the shortest side. The side that is opposite the largest angle is the longest side. So just kind of keep that in mind. So that when we're talking about the Pythagorean Theorem, the hypotenuse must always be the longest side. Other common triples that we have, 5, 12, and 13. So as you do problems in MyMathHub, as you do problems in the textbook, you're going to see 3, 4, 5, and 5, 12, 13 show up quite frequently. Other ones that we see a lot would be 8, 15, 17, 9, 40, 41, and 7, 24, 25. And again, you can check all these. You can verify that if I take 5 squared plus 12 squared, I get 13 squared. Easy enough to verify that. Now, one of the other neat things about Pythagorean triples is that we can take any of these ratios, and because we talked about similar triangles before, if I multiply each of these lengths by the same number, or even divide by the same value, I would have another Pythagorean triple. So you could take something like 3, 4, 5. This would have the same ratio as if you had 6, 8, 10. In fact, if we just double the length of each side, you would have another triple that is valid. So the ones that are listed in your notes and the ones that I have listed right here, these guys are all, completely reduced and simplified because something like 6, 8, 10 really comes from 3, 4, 5. You could also see something like 30, 40, 50, right? You just want to get used to seeing these guys. Okay, so again, practice with these. be familiar with them, because again, we're going to see these guys show up quite frequently. Now, with the Pythagorean theorem, and let's rewrite this just a little bit differently, write kind of backwards. C squared is a squared plus b squared. This becomes the basis for our distance formula in from college algebra that would say this, that your distance is equal to the square root. Now, this is the way I write it, as the change in x squared plus the change in y squared. If you were to look at what is in the textbook, they would have it written like this, that the distance is equal to pretty much the same thing that I have above, except that they actually write out what the difference of x would look like, y, or x2 minus x1, and the change in y, that difference would be y2 minus y1. So that's what the textbook says. Again, I tend to do a lot better when I'm just trying to find the change in x and the change in y, because I don't have to worry too much about the signs, because with this application of the Pythagorean theorem, you're going to end up squaring those. So whether the change is a positive or a negative, it doesn't matter, because you're going to square it. It's going to make it positive no matter what. So this distance formula is going to be used as we start to build our 6 trigonometric functions, which we're going to get to just a bit.